Wi-Fi. It's everywhere, right? It's this invisible magic that connects pretty much everything we do to the world. We use it every single day, but let's be honest, how many of us really know how it works? Well, today, we're going to pull back the curtain on this amazing technology.
It's a fantastic question when you stop and think about it. You plug one cable into the wall, and suddenly the internet is just floating around. It's on your phone, your laptop, your TV. So how in the world does that data make the jump from a physical wire into the open air? Let's get into it.
Just take a look at this. This scene is probably super familiar to you. Every single one of these devices is sending and receiving just massive amounts of information, and there's not a single cable in sight. They're all part of this giant invisible conversation happening all around us. And we're about to figure out exactly what they're saying.
Okay, so to really get a grip on Wi-Fi, we've actually got to zoom out first. We need to see where it fits on the bigger map of all wireless technology. You see, it's part of a much bigger family, and every member of that family has a very specific job to do.
Think about it in 4 different sizes. The smallest is what we call a WPAN, a wireless personal area network. Short-range stuff like your Bluetooth headphones connecting to your phone. Then you've got our main event today, the WLAN, the Wireless Local Area Network. That's just the technical name for the Wi-Fi in your house. Go bigger, and you've got a WMAN, which can cover a whole city. And the biggest of them all, the WWN, the huge cellular network that keeps your phone connected basically anywhere on the planet.
And wow, this really shows you the incredible difference in scale, doesn't it? On one hand, you've got tech that connects something just a few feet from you. On the other, you have this massive infrastructure that covers entire countries. It's just an unbelievable range. And our Wi-Fi, our WAN, sits right there in that local sweet spot.
All right, let's dive in. We know Wi-Fi is a WLAN, but what does that actually mean? What is the stuff that's carrying your data, your videos, your messages through the air?
At its core, it's pretty much what the name says, a local network without the wires. The entire point of a wireless LAN is to connect a whole bunch of devices in a specific area, your apartment, a coffee shop, an office, and, this is the crucial part, connect them all to the internet.
So you know that magic we were talking about? Turns out, it's not magic at all. It's radio waves. Yep, it's using the same basic principle as the radio in your car, just at a very different frequency. It's all part of this huge thing called the electromagnetic spectrum.
Now, most of the Wi-Fi you use today has 2 main frequencies, or bands, 2.4 GHz and 5 GHz. The easiest way to think about it is this. The 2.4 GHz band is like a busy 2-lane country road. It goes a really long way, and it's great at getting through obstacles like walls, but it gets crowded really fast and can be kind of slow. The 5 GHz band, that's like a brand new, multi-lane superhighway. It is way faster, with a lot less traffic, but it doesn't have the same long-distance range, and it struggles a bit more with walls.
So we know Wi-Fi is radio waves, but what hardware is actually doing all the work? Well, let's meet the team of players that gets the internet from that plug in the wall all the way to your screen.
First up, every single one of your wireless devices, your phone, your laptop, everything, has one of these on its team. It's a Wireless Network Interface Card, or NIC for short. Just think of it as the built-in antenna. It's both the mouth and the ears of your device, sending out and listening for those Wi-Fi signals.
Next is the home base, the device we all know so well, the wireless router. This thing is the coach of the team. It's the central hub that's talking to all of your devices, managing all the traffic between them, and connecting your entire little network to the giant worldwide internet.
Now, when you go to bigger places, like an office or a university, you'll see this pro gear, access points, or APs. See, your home router is kind of a 3-in-1 deal. It's a router, a switch, and an access point. But in a big professional setup, these APs are specialists. Their one and only job is to provide the best, strongest wireless signal possible, and a bunch of them work together to cover a huge area with no dead spots. So, this path right here is the whole ballgame. Your laptop sends a wireless signal to the router or the access point. That access point is physically plugged into a wired network with a cable, and that wired network is what carries the signal all the way out to the global internet. That's the journey your data takes every single time you load a web page. All right, we're at the last piece of the puzzle. We have all these different devices from all these different companies. How do they all manage to speak the same language? Well, just like any good team sport, they have a shared rulebook that everyone has to follow. That rulebook is a set of standards called 802.11, and its story is just one of incredible, explosive growth. Look at this. It wasn't just about raw speed. It was about getting smarter. New tech allowed routers to talk to multiple devices at once way more efficiently.
And the newest standards, like Wi-Fi 6, are all about performing well in really crowded areas. That's what made things like streaming 4K movies and playing competitive online games on Wi-Fi not just possible, but normal.
And who are the referees making sure everyone plays fair? Well, there are two main groups. You've got the IEEE, they're the engineers who write the super technical rulebook, the 802.11 standards. Then you've got the Wi-Fi Alliance. They take those rules and act like the league office, testing all the equipment to make sure a phone from one company can talk perfectly to a router from a totally different company.
So there you have it. Wi-Fi isn't magic after all. It's a brilliant system of radio waves, specialized hardware, and a common rule book that just keeps getting better and faster. We've seen it go from just barely fast enough for email to thousands of times faster. And that leaves us with one final, really exciting question to think about. What's coming next? What new, incredible experiences will this ever faster, ever smarter wireless world unlock for us?